All right. So this is the MCQ solution class for the Kinematics Momentum Paper 1 worksheet. We're taking broad questions from the kids. One of the kids have already given chat window is open here. Okay. Question number 7. 7 dekho. An object accelerates in a diagram in a direction that is always perpendicular to its motion. What is the effect, if any, on the acceleration of the object's speed and direction? Well, read the first sentence. An object accelerates in a direction that is always perpendicular to its motion, which means it has to be circular motion. Because in the case, only in the case of circular motion, the object's velocity and acceleration are always perpendicular to each other. What is the effect, if any, of the acceleration on the object's speed and direction? The speed would not change, the direction would change. Because in the circular motion, the force works radially inwards, so it does not affect the speed of the object. The object can have uniform speed, but every single instant it continuously undergoes acceleration because of this direction change. So I think C is the correct response, I believe.
Yes, sir.
Yes, sir.
Yeah. Tarbor?
Sir, number 11.
11. Dekbo. Yeah, number 11 is a nice question. It's a good one. 11, you might want to star mark this question. I'll explain this question piece by piece. Have a look. A box of mass 8 kg rests on a horizontal rough surface. A string attached to the box passes over a smooth pulley and supports a 2 kg mass at its other end. When the box is released, a frictional force of 6 Newton acts on it. What is the acceleration of the box? Okay, the first thing that I need you to understand, everyone to understand, that the question doesn't say anything about the elasticity of the string, so we might as well consider the string to be inelastic, but it is just a flexible cord that is attaching the box and the mass. Now, one of the key part that you can see from this figure is that whenever we let go of this system, this 2 kg mass is going to start fall downwards, and this 8 kg box is going to start move to the right. That is supposed to happen provided the weight that this 2 kg object experiences downwards, that is big enough to overcome the frictional force of this 8 kg box. If the frictional force is not overcome by the pull to the right side or the weight of the 2 kg object, then this whole thing is not going to move. Now, try to understand that how much is the weight experienced by the 2 kg object? What is that value? This force should be how much?
19.62.
19.62.
19.6. That's the correct response. 19.6 Newton. And as per the question, when we let go of the box, the frictional force is how much?
6 Newton.
On this direction, we have a frictional force which has a value of 6 Newton. Now, what you need to understand, consider this entire thing, box, string attached to the mass, as a single body. Because whenever this will go fall down, this will move to the right. If this one is moved to the left, this one is rise up. That at any point of motion, this string will attach these two objects and it will always be taut. Which means this one's velocity acceleration would be same as this one's velocity acceleration. Only the difference is that this is moving horizontally on the surface, this is moving vertically because it is hanging. Apart from these two direction information, they will have pretty much all the motion parameters exactly same. So they are they are connecting body. These two are making a single object who are connected by the effect of the string. Resultant force on this string should be how much? The resultant force on this entire system of 8 kg box and 2 kg mass should be how much? That is supposed to be 19.6 minus 6.0. If you wonder why am I trying to calculate resultant force, there is a reason. This gives you 13.6 Newton. Resultant force is given by mass into acceleration. calculate the acceleration of the box, I have to calculate the mass unit acceleration. Now the important bit is that this 13.6 Newton is responsible to move how much mass?
10 kg.
This 13.6 Newton object force is responsible to move a total of 10 kg mass, not only 8 kg, not only 2 kg. Get this. So if I place this equation over here, on this equation, if I go for replacement, this should be 10 multiplied by A. That should be 13.6. Ultimately, your acceleration is supposed to be 1.36 meter per second square. That's the correct calculation. And you should get a correct response for this answer. Answer is A. And student je bhulta kore, the typical mistakes that the students go by is that in some cases or in many cases, because the question is asking you to find out the acceleration of the box, in place of this 10, which is the combined mass of the system, they tend to place 8. If you do this, you are absolutely wrong, because what you need to understand, this 13.6 Newton force is not going to be responsible to move only the box. It's going to move the box and the hanging mass together. So the total mass of the system is exactly 10 kg, not anything less. Or in other words, I can tell you, if this question was written like everything is written in this fashion, only in this place this read, what is the acceleration of the mass? You'd have this exact answer. Both of them would mean the same mathematical procedure. See if it makes sense, everyone. If you have any question, please respond.
Sir, can you repeat?
Which part?
Sir, the part where you showed যে arrows দিয়ে কোন জায়গায় যাচ্ছে, কারণ আমি একটু লেটে জয়েন করছি স্যার, আমি বুঝি না।
The 2 kg object is providing the weight, which is working as the blue arrow, which is 19.6 Newton due to its weight, and the box is experiencing because of the rough surface, it is experiencing a frictional force of 6 Newton to the left. So the resultant force that the two objects all together experience, both of them together, is 19.6 minus 6.0. Because as the 2 kg object is going to move downwards, this box is going to start to move to the right. So this one's frictional force is going to start working to the left. So these two forces are in opposite direction compared to each other on this connected body of box and mass. But they're not exactly in opposite direction because we have a pulley involved here. The purpose of the pulley is to make a change of the direction of the force. All right, so we can move on. Yes.
স্যার 19.6 টা কোথা থেকে এসেছে আরেকবার বলবেন, আমার হ্যাং হয়ে গেছিল ডিভাইসে।
resultant force থেকে নিচে যাচ্ছে।
Yes. এই যে দেখো, F equals to W equals to mg.
ওকে স্যার।
Yeah, I labeled it, Fairuz. This one's weight will be the one of the available forces. This one's friction will be the one of the other available forces. These two forces will work in opposite direction. That's why I went for subtraction. As this one is trying to pull the setup downwards, this box is trying to move the setup to the left because of the friction. It's not actually trying to move it to the left. It is experiencing a resistance against the movement to the right. So together, the total force is the subtraction of these two values. বুঝা গেছে? I hope so. আচ্ছা, anything else from this page number 2?
Yes,
Anyone?
sir.
Okay, page
Sir,
number
sir,
3.
sir, page number 2 তে number 12 টা ছিল, sir, 12.
Okay, we'll go for it, no big deal. Question number 12 দেখো। Which of the following is a statement of a principle of conservation of momentum? Momentum is a product of mass and velocity. In an elastic collision, momentum is constant. The momentum of an isolated system is constant. The force acting on a body is proportional to its rate of change of momentum. Okay. Principle of conservation of momentum and basic content is that total momentum of the system before collision is equal to total momentum of the system after collision, provided the two objects collide in a closed system. Closed system means they are the only things which exert force onto each other. The colliding bodies are not experiencing any external force other than themselves. So which of these which information provides this? I think C pretty much holds the gist of the information. The momentum of an isolated system is constant. That looks good. Momentum is a product of velocity. No. In an elastic motion, momentum is constant. No. Saying momentum is constant actually never serves the purpose in any case. I mean, that's a vague statement. Momentum is constant. What do you mean by this? You have to specify the total momentum of the colliding bodies before collision is equal to the total momentum of the colliding bodies after collision. Momentum of an isolated system is constant. That also makes sense because I'll tell you why. Because whenever you say specify to be isolated system, it means that the total value of momentum will always be equal. That essentially covers the scenario of before collision and after collision within itself. I think C is the correct response.
Yes, sir.
Yeah, এই কোশ্চেনটা করছিল কে জানো?
স্যার আহনাফ ইসলাম।
হ্যাঁ, আনাস ইসলাম। বুঝে গেছে কি?
Yes, sir. অনেকটা।
Anything else from page number 2? Page number 3?
স্যার একটু উপরে যাবেন আরেকবার।
Definitely.
হয়েছে। থ্যাংক ইউ।
আচ্ছা। Page number 3. এখানে nope. I'm not expecting calls to receive. Anything from page number 3? Anyone?
Sir, number 25.
Number 25. Beautiful question. Number 25 to देखिए. A moving body undergoes uniform acceleration while traveling in a straight line between points x, y, and z. The distances x, y, and y, z are both 40 meters. The time to travel x to y is 12 seconds, and from y to z is 6.0 seconds. What is the acceleration of the body? Okay. So just to solve this problem, simply let's try to draw this whole figure so that we can essentially work with it. So let's say this is our entire segment of xz, and here is x, here is y, here is z. Both of these lengths are how much? Both of the lengths are 40 meters. And to cover these distances for a continuous motion, as per the question, this much requires 12 seconds. So, and this much requires 6.0 seconds. So both of the times are given in up to 2SF, 12 seconds, 6 seconds, 40 meters, 40 meters. All the numbers are given in 2SF. So this is y. Y লেখা হয় নাই। Okay. So what is the acceleration of the body? There are two different ways to try to solve this problem. I'm gonna cover both of these ways and the probable problem to go for this problem thing. This question does not say anything about whether the object did have some initial speed or not. So you cannot simply assume that initial velocity was 0. This is the most common mistake that the kids do. You cannot do that. You have to assume the object might have had some initial speed at the point of x. Initial speed might have been something. You cannot assume it to be 0. Now, that's the first part. One of the ways that that should make sense to you is that, the most common response that the students go by for this problem is they try to apply the formula, the third formula, which is s equals to ut plus half at square, ut plus half at square. They try to apply. This is the basic formula that by which we are going to solve this problem. So if you want to apply this formula for these two segments individually, so if you apply this for xy segment first and then yz segment afterwards, you can essentially solve this problem, but there's going to be a slight bit of trouble. That slight bit of trouble is that try to understand the velocity at point y. It will be the final velocity of xy segment, and it will also be the initial velocity of the yz segment. If you look at this equation, it works with s equals to ut plus half at square. So it works with the initial velocity, time, acceleration, and time. So to be able to solve this problem, you need the initial velocity of this object for the relevant amount of motion that you are considering. So one of the ways, which in my opinion is not the optimum way, but I'm still going to show you because you need to understand what I'm trying to say. One of the ways to approach the problem is this way. If I go for the two segments individually, so I can write, let's say, 40, only writing for the xy segment. 40 equals to u into 12 plus half a 12 square. See if you can appreciate this equation. I wrote s equals to ut plus half a square for only segment xy. Then I can try to write the equation for yz. Now the problem that I'm gonna run into that if I try to write the equation for yz, then I need to have the velocity at this point. Now what should be the velocity at this point? You have to calculate the final velocity of the segment xy to find out the velocity of y point over here. How can you do that? Now, try to understand. This object was assumed to have initial velocity of u. It has a duration of 12 seconds. So if I just write the formula for final velocity, v equals to what? U plus at. Remember this equation? Pulavan, খেয়াল করো. This is the equation for final velocity. So the point that I'm trying to make, that final velocity after xy segment is the same as initial velocity before yz segment, because the motion was said to be described to be a continuous motion. So in this case, I can write for the yz segment, I can write (40) equals to ut. U was u plus check this out. See if this makes sense. So I did not write the u in terms of the u in the first place because I cannot only write ut because both of the segments are not supposed to have the same initial velocity. So I wrote the final velocity after segment y. So you have two equations over here. Have a look. 40 equals to 12u plus half a 12 square, and then you have this equation as well. Both of these equations have two unknowns, u and a. You just have to sum them up, merge them up, arrange them up, and solve this bivariable equation, and you can find out the value of u and a. You should be. Do you guys know how to solve bivariable equation by your calculators?
Yes, sir.
Yes, sir.
Everyone. আচ্ছা এখানে 12 লিখছি, এখানে টিটা হবে না, টিটা কত হবে? This one is not supposed to be t. For YZ segment, what should be this number?
6.
6.
Supposed to be 6. Yes, I actually forgot to write 6 over here. Okay. So
Sorry,
that's one way to solve it, but I do not recommend this way. The easier way to solve this problem is if you go for segment XY and XZ. That pretty much solves the problem to a much simpler version of the formula, which is easier to solve. The equation for XY remains the same. XY equation goes by 40 equals to u into 12 plus half a 12 squared. That is good. And then if you go for the segment XZ, if you wonder why XZ, because we can pretty much do this whole sum for the XZ segment as well, because the question says that the acceleration was same through the entire motion. So we can work for the XZ part. So if you go for the XZ part, what is the benefit that we're gonna have? Here's the benefit. For the entire XZ scenario segment, your total distance covered is 80. Your initial velocity is still u, whereas the total time that you require is 18 seconds. So ut plus half a 18 squared. You see, now these two equations become much more palatable, much more workable compared to these two equations, because here you have a lot more work to do. So I recommend these two set of equations. However, these two set of equations are not despicable. You can also solve the problem by these two equations as well. So these are the two set of equations you have to work with. Give it a try and come to a solution. Find out the numbers of u and a. The question asks you for the value of which one. Question konta jaise? Only the acceleration is asked for over here. Okay, so solve these two equations and see how much you get. I can help you solve this equation.
Sir, 0.37.
Solve করে 0.37 আসে?
Ji sir.
Yes, sir.
আচ্ছা তাহলে তো হইলই। আমি এটা কেন দেখাইছি বুঝছো? The reason I have shown you this part is because I personally like this version better. This is easier to work with, but the only reason I'm showing you this part as well is not to confuse you, but because of one reason is that let's say this problem shows up in your exam. You forget that you are supposed to do this, and you are going for your natural response that I'm going to apply s equals to 2 plus half a square for each of these segments individually. So you are going to start attempting that. And the reason I'm showing you this in the first place, to get the information in your head that at this point, the velocity is not u. You cannot use a bold u over here. This velocity, initial velocity for the YZ segment should be expressed as the final velocity of the XY segment. That is extremely important. Just to get this information through your head, I showed this thing first. Does it make sense to everyone?
Yes, sir.
Yes, sir.
Achha.
Yes, sir.
Anything else from this page? Page number 3, that is. Could you solve number 23?
Yes, sir.
Number 23 is a good problem. You just have to do one.
Sir, তো 1.2 square করতে হবে আর কি।
হ্যাঁ, exactly. 1.2 square করলে 1.44x চলে আসবে। Yes. আচ্ছা, page number 4 actually ভেজালের কিছু নাই। Doesn't affect terminal velocity. Okay. No. Does it? No. Question number 29 একটু দেখো। Question number 29 একটু আলাপ করি। Have a look at question number 29. A body falling in a uniform gravitational field encounters air resistance. The air resistance increases until terminal velocity is reached. Which factor does not affect its terminal velocity? Does not affect its terminal velocity. So terminal velocity not affecting terminal velocity. Sorry. Which factor does not affect the value of the terminal velocity? That's the bit that they are asking. Which factor does not affect the value of terminal velocity? So we have a lot of factors mentioned over here. The density of the air, blah, 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 blah. Let's try and consider each of them one at a time. The density of the air will definitely affect the value of terminal velocity, because if the air is dense, the falling body will collide with bigger number of air molecules as it falls down per second. So increased number of collision will essentially give you a higher air resistance. So more dense air is capable to give you smaller terminal velocity, because you can achieve the upward force equal to the weight at a lower speed, and blah blah blah. Sita will say the mass of the body. Mass of the body is always very important, because mass of the body multiplied by g gives you the weight, which is your downward force. So if you have a larger object, naturally it should have a higher terminal velocity, and a smaller object should have a less terminal velocity. One of the example of this is that if you recall from your regular experience, whenever rain falls, if it drizzles, you cannot almost sense that water drops are falling on your skin or anything, because you get wet, but you don't essentially sense the pressure on your skin. But when the rain starts to fall in large drops, you actually can feel it hitting your skin. The idea is that whenever both of these drops, as they start falling from the rain clouds, they pretty much achieve their terminal velocity beyond a certain point of their fall, and beyond that, and upon reaching their terminal velocity, for the rest of the motion, they keep on falling at the exact same terminal velocity. But for larger airdrops, that value is higher. They fall even much more faster compared to smaller airdrops. This is why whenever the larger raindrops hit our skin, we can actually sense that something is actually falling on my skin. You can actually sense that pressure variation or the force being exerted on your skin. Whereas for small rain droplets, like for the case of drizzling, we don't even sense that. So that's a very important bit. C number says the height from which the body falls. This is the correct response. B number, sorry, I went for A and then I went for C, my bad. B number is the correct response. I'll talk about B in a bit, but I'll just have to talk. I want to talk about D first. The shape of the body does actually affect the value of terminal, affect the value of air resistance, because the shape of the body means that if you have an aerodynamic shape, round shape, or parabolic shape, or a bullet kind of shape, or a dolphin kind of shape, you can have you can reduce air resistance or fluid resistance significantly. Whereas if you do not have an aerodynamic shape, your object looks like a box or the flat face of a cylinder, you're going to have significant air resistance properties. So shape does affect. Now, the height from which the body falls does not affect because of one thing. Here's the deal that I need you to consider. Whenever you drop an object through air, it is going to fall through a certain height, and upon falling a certain height, it will naturally reach terminal velocity. Upon falling a certain height, it will naturally reach terminal velocity. What I mean is that after the object reaches its terminal velocity, from that point onwards, it is going to continue its fall at the terminal velocity. So if you have a consider for a scenario over here, let's say I'm going to use this much space for this explanation. Let's say you are dropping two objects. Let's say one is a steel ball and the one is a plastic ball. They pretty much have the same shape. It doesn't have to have the same shape. They're two different balls, and the ground is pretty far down. Let's say this is the top floor of Burj Al Khalifa. So you're gonna drop these objects from a really tall height. Well, the steel ball and the rubber ball, let's say, or plus a plastic ball, well, you do understand that this one has a much higher density. So for the comparable volume, this one gonna have a much bigger weight. So much bigger weight means to balance this force, you'll also require a much bigger air resistance. So it's gonna fall through this much for vertically downwards. Sorry, it's going to fall vertically downwards, and upon falling a specific amount of distance, it can eventually reach its terminal velocity. Let's say that distance is, let's say, 1 kilometer, so, or 1,000 meter. I'm assuming these numbers. These numbers are not pragmatic. These are just some numbers. And let's say for the plastic ball, that distance by which it should fall and reach that terminal velocity, let's say that is only 200 meter. Now, what I want you to understand, these two things, values, to 1000 meter and 200 meter, these are independent of the of their actual height from the ground, from where they are released. If the steel ball was released, let's say 2 kilometers above the ground, it's gonna still reach its terminal velocity after 1000 meter of fall. If this was released from a maximum height of let's say 1.5 kilometer above the ground, ওইখানে কিছুতে ঢাকা রাখো, ফ্যানের বাতাসে সব ঠান্ডা হয়ে যায়। Thank you. So if the steel ball was dropped from 1.5 kilometer or 1500 meter above the ground, it would have reached terminal velocity after 1000 meter of falling. So, or in other words, it would reach the terminal velocity 500 meter above the ground, and so on and so forth. I mean, the steel ball requires 1000 meter of vertical fall to reach its terminal velocity, period. So it does not matter exactly from what height do we drop this steel ball. As long as we allow the steel ball to fall by 1000 meter through atmosphere, it will reach terminal velocity, period. So the height of the ball from which it is released essentially does not affect the terminal velocity, as long as the object is allowed to fall through enough height to reach its terminal velocity. If you make sure that the object will ultimately reach its terminal velocity within the amount of fall, then in that case, from which location you are dropping the object really does not matter at all whatsoever. That's why for that question, which of the fall factors does not affect terminal velocity, B is the correct response. Do I make sense, everyone?
But sir, what if the height is too small?
Well, if the height is too small, then the object might not reach terminal velocity as well. In that case, the existence of the question is futile. The question doesn't apply to that scenario. Which factor does not affect its terminal velocity? It means that if you want to make a comparison among these four factors, you have to have a scenario where the object will or already have achieved terminal velocity. If the object is dropped from a very small height, then it's not going to achieve terminal velocity. So there is no question of comparison. Did you get my point?
Yes, sir.
Okay. So next one, 2.2. I think we did attempt some problems from 2.2, I believe.
Yes, sir.
Yes, sir.
I think so, yes. This problem looks a bit similar. Okay. I think we did discuss about this one. AJ, I think this is the last problem that we discussed in some of the classes, that this answer cannot be equal to 4 MV, this cannot be equal to 2 MV, this will be something in between. The only choice was 3 MV.
Yes, sir, we discussed.
This was the last problem that I discussed in some of the classes. Okay, and we started discussing this one, and then we finished the class, I believe. Did you discuss this one?
Yes, sir, we did.
No, I didn't.
Yes, you did.
Did I finish the
এটা পুরো না ডিসকাশন শেষ হয় না স্যার।
discussion session? I was halfway through it. Yes, that's what I
Yes, sir.
remember.
Trying to explain this, you went to another question from all of us.
তারপর স্যার আপনার ঘুম পাইছিল।
এটা কবে ছিল?
এটা হচ্ছে লাস্ট থার্সডে বা লাস্ট ওয়েডনেসডেতে।
Okay. আচ্ছা, ঠিক আছে, সমস্যা নাই। I'll discuss this one. Have a look. Let's continue with this one. A group of students investigating the principle of conservation of momentum use a small truck traveling over a frictionless surface. Sand is dropped into the truck as it passes X. At Y, a trapdoor in the bottom of the truck opens and the sand falls out. How does the velocity of the truck changes when the sand is added to the truck at X and then leaves the truck at Y? Now, what I could have an unanimously decision from all of you or each of you is that when the mass was or the sand was being added to the trolley at position X, all of you agreed that its velocity should decrease. Do you remember? Because the idea is that the incoming trolley has some momentum, So it has some mv. If you add some sand at position x, those sand particles did not have any velocity to start with. The moment they will hit the trolley surface or the body of the trolley, they will be pushed by the trolley's existing momentum, and they will be given some momentum to move along with the trolley. So the momentum that the trolley had in the initial case, this will now start to get shared in a bigger amount of mass. Let's say the momentum of the trolley was before it reaches before it was coming to the point x was 100 unit, and then and then let's say the mass was, let's say, 50 units, so the velocity was 2. So if you now start to apply bigger amount of mass which was initially at rest, so now you're gonna have bigger amount of mass compared to 50 units, but your momentum was still very much the same because you did not apply any additional force, and the momentum would still be very much same because we are not applying force to accelerate, neither are we applying force to decelerate. We are not doing any of these. We are not doing any of these, so that's why we are not having any of these forces available. So at that scenario, we are gonna have this one happening, and so this is okay. So for the first column, the answer cannot be C or D. We are pretty much settled on this one. What happens when the trapdoor opens and the trolley starts to lose sand? Now, before I get into this question, before I get into this idea, I need everyone to look at the question very clearly and tell me, how is the surface?
Frictionless.
The surface is frictionless. Do you see that? Did you find that? The
Yes, sir.
surface is frictionless. So now, what happens on a frictionless surface? A frictionless surface is something that if something is moving on the surface, this should be able to move on forever, right? There is nothing to stop that object. There is nothing to stop that object, which means if at position Y, when the trolley reaches position Y, and the trapdoor opens and sand starts to fall out of the trolley, what happens to those sand particles as they fall onto the trolley? Yes. Should the sand get stuck to the surface or what?
It won't be stuck there.
Did you guys get my question?
Sir, can you repeat?
When the trolley will reach position Y, let's say this is now position Y, and now let's say here opens a trapdoor. So let's say this is the position, and let's say here opens a trapdoor. I would like to open this up. So let's say, and the sand is just starting to fall down from the trolley onto the ground. My question is, what's going to happen to these sand particles as they hit the surface? Should they stop?
No, sir.
No.
Think.
They fly backwards.
Well, the collision with the sand particles with the ground are not mentioned to be perfectly elastic. So bouncing off with the same velocity might not be a good idea. They might still get attached to the, they might still remain in contact with the ground, but they will not stop, or they will will they slow down. What this means, which is very disturbing for us to visualize, is that as the sand particles come out of the trolley, this sand is gonna start piling up at this point. And as the trolley moves forward, this pile is also gonna slide along with the trolley. Can you visualize that?
স্যার একই ডিরেকশনে স্লাইড করবে
Yes, I'll help you to visualize that. I'll help you to give you the reason. The sand does not get stopped because the surface is frictionless. So as the sand falls out of the trolley, It maintains its momentum. Because to reduce its momentum, you'd require some force to be exerted on the sand. Is there any force in the horizontal direction on these sand particles which are leaving from the trolley? Answer this question. Exclusively this question. Is there will the sand particles which fall out of the trolley because through the trapdoor, do they experience any horizontal force?
No, sir.
No,
So if they do
sir.
not experience any horizontal force, whatever the velocity that they did leave from the trolley, should that velocity remain intact or should it change?
Sure.
Intact.
Intact.
Yeah.
It should remain intact. So remaining intact means what? That they maintain that velocity, which means they will keep on moving with the trolley as the trolley is moving by.
Sir,
Yes.
shouldn't they provide friction to the truck when to the trolley?
Well, that's not supposed to happen because the question already says that the surface is what? The
Sir, should
surface is frictionless.
The surface is frictionless, but যে sand গুলা যখন পড়বে তখন ওগুলা friction provide করতে পারে না ট্রলিটাকে?
Well, they might provide friction to the trolley provided the heap of the sand becomes large enough that they actually make a contact with those wheels. So you would require a huge amount of sand to be falling down.
sir, will the
Is
sand not
gravity
lose
not a
momentum
factor?
Gravity is
with collision with the ground?
gravity is definitely pulling the sand particles down, but it is not slowing them because the surface is frictionless. Gravity would have been a important factor or a valuable factor if there was some friction available, which might slow down the sand particles. If there is a friction available, which is a regular case scenario, which we can easily comprehend and analyze, for a situation of friction available, these sand particles would produce a trail as the trolley moves forward. But for a frictionless case, that would not be the scenario because you cannot have a trail because those sand particles are not being stopped by any force. So they are going to keep sliding as the trolley moves forward. This is very difficult to visualize, but that is pretty much the case as the question specifies.
Sir.
একটু দাঁড়াও আরেকটা কেন কোশ্চেন কিছু একটা বলতেছিলা I was speaking through their question. এটা একটু বলো লাবিব কিছু বলতেছিলা
Sir, will the sand lose momentum with collision with the ground?
No, that's the whole point. Because the surface is frictionless, so the sand will not lose momentum. So this is very much similar as the ইফাত কি বলতেছিলা
কিছু বলতেছিলাম না।
আচ্ছা
আমি বলছিলাম স্যার
হ্যাঁ বলো
স্যার যেহেতু লাইক ওদের মোমেন্টাম চেঞ্জ হবে না তো দে উইল কিপ অন মুভিং তাই না তাহলে মানে ওরা ইয়ার হুইলস গুলোর সাথে কেমনে কন্ট্যাক্টে লাগবে যদি মানে কেমনে লাগবে
কার সাথে
ইয়ার ট্রলির হুইলস গুলোর সাথে যদি লাগে
ও আচ্ছা মানে সাদিয়ার কোশ্চেনে যেটা বলছিলাম সেটা বলতেছো let's say this heap of sand becomes big enough and enough big enough, so much big enough that eventually you have this wheel to start trying to roll over this heap of sand. If that's a scenario, but that's hypothetical because it's not essential that this heap has to be over here. You might also have this heap, this trapdoor located on the behind side over here. But that's a pretty far-fetched scenario because the question does not say that what happens to the speed of the trolley really far away down the track. It says that what happens at y. At y means what? Instantaneously at y, what happens? As the sand starts to leave out of the trolley, what happens at y? So that question of whether the trolley should be affected by that heap of sand is not a scope of this question. The question does not cover that much information. বুঝতে পারছি আচ্ছা so this is a scenario of a situation like this it's like this let's say so as the both of the objects are moving in the forward direction by the same amount of speed, so momentum of both the objects would remain pretty much same. The only difference is that the sand will now not be contained within the trolley anymore. But as the sand leaves out of the trolley, they take away their own momentum. So the let's say if I just give you some numbers, let's say this thing initially, try to visualize this. Let's say initially with along with the sand and everything, let's say the total mass of this thing was 200 gram, where there was 150 gram of sand, let's say, with 50 gram of trolley. ঠিক আছে? Let's assume this is a specification that we have. Trolley. So, and let's say the speed of this whole thing was 2 meter per second. So the total momentum over here was 400 gram per second, which makes sense. Let's say the trolley opens and some mass falls down. Let's say 5 gram of sand falls down. So if the 5 gram of sand falls down, this sand will take out 5 gram into 2, that is 10 gram meter per second amount of momentum. So this will take out this much amount of momentum for its own self. So the entire trolley would be left with how much momentum? The trolley would have a remaining mass of how much? Initially the mass was how much? I assumed 200 gram. I'm showing you these numbers to give you an idea of comparison. These are not concrete numbers, or these are not realistic numbers, but they will be mathematically sensible. So if 5 gram sand falls out of the trapdoor, how much would be the remaining mass? Balawan. Dekho, this was the starting mass to start with.
295 grams, sir.
Not 295.
Oh, 195. Sorry, 195.
195 gram would be left for the trolley and the sand and the trolley all together, because 5 gram sand fell out. And this sand took out 10 gram meter per second of momentum. So how much would be the remaining momentum for this trolley? Initial momentum was supposed to be how much? The product of these two. If you multiply these two numbers, how much do you get? 400 gram meter per second. This was supposed to be the initial momentum. So if the fallen sand takes out 10, you would have 390 gram meter per second. Can we agree on this fact? Now, if you just do a ratio of momentum versus divided by mass, you're still gonna get 2 meter per second. Now, I might not as well require to show you this math. The only reason I'm showing you this mathematical calculation as a sample to convince you of the fact that this is gonna be true. You're still having 2 meter per second. The idea is that these two objects, I mean the fallen of sand and the trolley, they are not in contact with each other currently. They are not a single body. They have detached, but they're still moving side by side. They are not exerting force onto each other as they are living from one another. So, or in other words, you can say, I mean, I cannot think of a practical scenario that could possibly replicate this, because in all practical scenarios we have friction. Yeah, in all practical cases we have friction. So I cannot think of a scenario where this can be happening.
Let's just assume that it's on glacier ice.
Okay, if we assume it to be on a glacier of ice, so let's assume let's assume on a ice slope we have a very very light slope, and there are ice skaters which are moving by. So let's say here we have one ice skater, and here we have another ice skater, and there is the skate that we have. So let's say this is the skate that we have. So they are moving forward at a constant velocity, let's say. For whatever reason, beyond a certain point, this skate cracks into two pieces. Okay, so let's say the skate got cracked into two pieces. Now the point was that they were individually supporting their own weight, and by using the component of the weight, they were overcoming the minimal friction that they had between the ice surface and the ski. So even if this thing cracks by a little bit, I actually made a large gap showing up over here. The gap shouldn't be there. It just broke into two pieces, but there is nothing to actually make them far apart. They can still very well maintain their original speed because they do not have any new force to slow any of them. I mean, he's not going to slow a fast speed up on this direction because he's not suddenly having a bigger amount of mass of its own. He's not going to start slowing down because once again he's not having a bigger amount of friction for his own self compared to earlier. So they are still going to be moving, being in contact with each other exactly the way they used to be. Only that now they are not on the same body. They have two pieces of body on which they are moving forward. Does that example anyhow make sense? Because if you don't have any question, I'll move on. If you have confusion, respond. Anyone?
স্যার তাহলে এটার অ্যান্সার কি বি হবে?
এটা আনসার বি হবে। Yes.
তাহলে স্যার এই যে এই ফলিং অফ স্যান্ড পার্টিকেলস এগুলোর কি কোনো ইফেক্ট ছিল না? মানে ফলিং অফ স্যান্ড পার্টিকেলস ইনটু দি ট্রলি এটা কি মানে কোনো ইফেক্ট ছিল না?
Into the trolley সময় অবশ্যই যে আমাদের তো ডিক্রিজ করতেছে।
ও
At X position, when the sand was added to the trolley, the momentum would decrease. But as the sand falls out,
থাকবে কেন স্যার? সেটা
সেটা তো আমি এতক্ষণ ধরে ডিসকাস করলাম। বলো কোন পার্টটা বুঝো নাই?
স্যার পড়ে যাওয়ার পর তো লাইক ট্রলি টোটাল মাস কমে যায় না?
আবার বলো। সরি বুঝি নাই।
স্যান্ড পার্টিকেলস গুলো যখন পড়ে যায় ট্রলি থেকে তখন তো ট্রলির মাসটা কমে যায় না, টোটাল মাসটা?
Yes, I showed you the total mass কমে যাবে for a sample calculation. Yes, and the mass which will leave from the trolley as they fall out of the trolley, they will also take a portion of the available momentum of the trolley. 5 grams sand to our steady position পড়ে যাবে না because it was at a moving condition with the trolley being inside the trolley. So as the mass falls out of the trolley, they also take out their significant portion of the momentum along with them. So as the mass reduces, simultaneously reduces the momentum as well. The ratio pretty much remains the same. বুঝছো কি? আচ্ছা, so you are considering that this is going to happen but this was not going to happen, right?
কিছুটা
Yes, but both of them will happen. As the mass falls out, the momentum is also being taken out from the system as well at the same time, simultaneously. All right. Next, anything else that you have over here? I want to solve number 40. Number 40 is a pretty interesting problem. Students usually make a lot of mess for this problem. 40 একটু আমরা দেখি। Have a look. A lead pellet is shot vertically upwards into a clay block that is stationary at the moment of impact, but is able to rise freely after impact. The pellet hits the block with an initial velocity of 200 meters per second. It embeds itself in the block and does not emerge. How high above its initial position will the block rise? Okay, so mass of pellet হচ্ছে 5 gram, mass of clay block হচ্ছে 95 gram. আচ্ছা, এই প্রবলেমটা সলভ করার দুটো উপায় আছে। আমি দুটো উপায় বলতেছি, একটা হচ্ছে ভুল উপায়, একটা হচ্ছে কারেক্ট উপায়। প্রথমে ভুল উপায়টা বলতেছি। Let me tell you the wrong procedure to solve this math. The ideal or most common wrong procedure of this problem is that if you go for if you go for equating energy means that this lead pellet is rising up at 200 meters per second. So it will hit the clay block with some kinetic energy, right? You can very easily calculate that kinetic energy. How much is the kinetic energy of this lead pellet? This should be half into 5 into 200 squared. If you wonder why didn't I convert this 5 into kg, because I'm gonna maintain gram on the right side as well, so I can equate this out. So one of the key understanding is that the amount of kinetic energy that this block will bring to the block, to whenever they will merge, they will go up to get a GP at the highest point of motion that will be equal to this initial K. So whatever the K that this lead pellet provides to this stationary block, that thing will be converted to the combined GP of the block and the pellet together. So this is the K that the lead pellet is bringing to the system. As a result, the total GP might as well be what? 95 plus 5 into 9.81 into H.
স্যার বুঝি নাই।
মামুন, এটা বাই করো, অসহ্য লাগছে শব্দ। দেখো বুঝছো কিনা, এখন বোঝা যাচ্ছে? What I'm trying to show you, I'll describe what I just did. That before the collision or before the merging, the lead pellet brings in lead pellet with mass 5 gram comes in and impact with the stationary block at 200 meter per second, which brings in some kinetic energy to the system. This was the object which brings in the kinetic energy. After the collision, that combined mass becomes 100 gram. And let's say this combined object is going to rise up by a height of h, maximum height of h, because this thing is going to push this object upwards. So if we assume that this height is h, so you can pretty much get that this the total amount of GP that is stored over here is how much? mgh. So m is the 100 gram, g is g, that is 9.81, and let's say this height is h. If you wonder why am I trying to do this, because that's the question. How high above its initial position will the block rise? I'm trying to calculate this h. বুঝে গেছে কি?
জি স্যার।
Achha. So let's say this is one consideration, but where you are trying to equate the two energy contents earlier and after, you can pretty well very easily you can very easily calculate the h value from this two expression to get a fixed number over here. You can. Now, this would be wrong. Tell me why. Guess why?
Kinetic energy can be lost in collision. It doesn't have to be an elastic collision.
Inelastic collision.
This is not an inelastic collision. Some kinetic energy would be wasted in some other form. If you think of the very primary reason, whenever the lead pellet will actually hit the stationary clay block and get merged together, so this is a case of two objects getting joined together. Those cases, the case of joining, are never elastic collisions. So some kinetic energy will be converted to some other form. In more practical sense, if you try to visualize it, as the lead pellet will enter into the stationary clay block and remain inside, it has to physically do some plastic deformation for a small part of that stationary clay block, because it will have to replace the stationary clay block molecules to make its own path and enter into that position. Whenever the lead pellet gets stuck inside the clay block, it will actually have moved some of the molecules of the clay block permanently. That permanent movement would require some physical work done, which has to come from the initial kinetic energy of this lead pellet. So all of these lead pellets kinetic energy will not be converted into GP. To tell the truth, this will be converted, some portion of it would be converted to GP, and there will be another portion which should be converted as the EP because of the permanent deformation, which we did not take into consideration for this part, but this will also exist. Now, if you wonder, can we not solve this problem in this fashion? The answer is a solid no. You cannot solve this problem in these equations. Using this equation in the first place is wrong, because you do not have any measure, or you don't have any information how much was the wasted energy for this plastic deformation as the lead pellet got absorbed in the stationary clay block. So you cannot do this. I'm showing you this first before showing you the appropriate way, because I want you to grasp this idea very clearly that you cannot do this, because when this question will actually show up in your actual exam, let's say in your S level exam, you would not know that from which chapter this question is given from. This might be a captured question from work energy power. This might be from kinematics. So you don't know. So you would try to apply the physics logic that you have within yourself to solve this problem. So it's very common that the kids try to solve this problem equating the energy amounts and they get a wrong answer. So don't fall for that. So the other way that we can try to solve this thing is going for the basic kinematics procedure, which happens to be pretty simple. You have to judge this situation in a two different step. So I'll take my question and start a new solution space. The other way we can try to solve this problem is that, let's say here is the situation that we have, and we can divide this entire question into two parts. What are the two parts? First, there will be a collision, then there will be rise. So we can find out the final velocity of the two common bodies using the idea of collisions. So if I go for this one, I can write that 5 into 200 plus 95 into 0 should be equals to 5 plus 95 into V. Check this out. M1 V1 plus M2 V2 equals to M1 plus M2 into V. So I'm trying to find out the combined final velocity of the two objects when they get merged together. So what will be the value of this V? Give me this number. এটা কত আসবে?
10.
কত আসে?
10.
10.
Yes, sir. 10.
Exactly.
Yes.
Wow. So the final velocity is 10 meters per second. Once we have this number, then finding out the final height is pretty simple, because we know that V square equals to U square plus twice S. Now you have to understand one thing, that if I write this equation for the final velocity, I might as well write that 0 square equals to 10 square plus 2 into 9.81 into H. Right? দেখো বলবান, the key idea is that you cannot place this one to be 10. You have to understand that this is the collision case. So if you divide the whole scenario into two parts, first there will be collision. After the collision, the entire combined object of a block plus mass, or for example this thing, this will gain a final velocity. Let me just copy this part.
So I did not understand which equation you used for the collision.
This one.
Yes, thank you, sir.
Sure. So here I divided the equation into two parts. So first of all, we're going to have collision. After the collision, the object would have some initial velocity, and then this object is going to rise up to a certain height and come to a stop position at its maximum height. So we did this using this part. We calculate the initial speed of the rise, and obviously at the highest point of the motion, when this whole thing comes to the highest position, then the final velocity is supposed to be 0. So in this equation, this 10 is not supposed to be placed here, because if you place it over here, you are not going to get a correct answer. You should place it over here. And also, to make sense of this equation, I mean, you might as well, for an MCQ question, that's not a bad thing. You can place it over here and still get the correct answer. But here's the deal. Here, the acceleration is working downwards, but the height is working upwards. Do you understand these two parts? As the object rises up, there are two vector quantities: height, displacement, and the acceleration is already a vector quantity, which means logic tells us we should place a minus sign in front of any of these. Typically, we place the minus sign in front of here, in front of the acceleration, because downward is considered to be negative. This is supposed to exist here. If we do not give this equation, this minus sign over here, in a paper 2 question, we are going to lose mark. In a paper 2 question, we are definitely going to lose mark. বুঝা আছে কি বলছে?
Sir.
So in a paper 2 question, you have to place final velocity of the rise to be 0, initial velocity of the rise to be 10, which we obtained from here. So the final velocity of the collision is the initial velocity of the rise. You can put it that way. I should have said this earlier. Because so এখান থেকে calculate করে দেখো h value কত আসে. How much do you get for as the h value?
5.096, so basically 5.1.
So 5.1 is the correct response. That works.
So after we find out the velocity after collision, can we use kinetic energy equals to G because of GPE? Like half mv squared equals to mgh.
I think you can.
Because in this case, there are no more collisions.
I never thought of that, but I can try.
We get the same answer.
Half into 100 into 10 square should be equals to right. So you lose this, you lose this. You should get the same number, right?
Sir.
Because this is the same equation. Yeah. If you calculate the final velocity out of this equation and then go for the equating of the kinetic energy and GP, that can work. That can work as far as I'm concerned. But then again, if you go for this one, if you go for this step, there is usually no logic to go for this one once again, because this you have a much simpler equation to work by. But you can, different brain can work different way. But yes, the answer to your question is yes. After you find the final velocity, you can go for this equation and get the correct answer again. Yes, correct.
I did use v squared equals u squared plus 2as at first, but then I was like, can we do that too?
Yeah, you can do that too. Yes, the answer to your question is yes. So বুঝা গেছে এই প্রবলেমটা সবার? Everyone?
Yes, sir.
Okay. It's 3.06. We didn't do much because I was, as always, late for this class. আচ্ছা শোনো পোলাবান, তোমরা বাকি প্রবলেমগুলো ট্রাই করবা। তোমাদের এরপরের ক্লাস কবে?
Tomorrow.
কালকে কয়টায়? 5:30 না?
Yes, sir.
Yes, 5:15 থেকে 7:15. Okay, I'll be definitely on time and we'll start pretty much exactly on the dot. So yes, try to complete this up, this MCQ paper as best as you can. If you do attempt enough problem from this MCQ paper, this entire MCQ paper should be enough to take care of tomorrow's class. But if you don't, and I am allowed to move pretty fast, I will start the paper 2 worksheet tomorrow if we can finish the paper 1 MCQ paper. So you are just having a homework of this paper 1 MCQ paper and also the paper 2 paper as much as you can go forward. Thank you, everyone. And Zara and everyone who called me, I really appreciate your calls. Yes, thank you very much for calling and waking me up. Assalamu alaikum.
Welcome, welcome, sir.
হ্যাঁ
বলো।
হ্যাঁ তাহলে কি করবো?
হ্যাঁ